This tutorial is meant to go with a Cisco CCNA curriculum, CCNA2 routing protocols type curriculum, coordinated with Chapter 3 in the routing and routing protocols CCNA curriculum. Okay, the goal in this is mapping essentially to what we would have in a CCNA, like in a skills integration challenge, where they give you a picture of the network and they want you to subnet this network. Okay, so in this picture, they've told you that they need you to subnet this network right here, and this network right here, and this network right here, and this network right over here. And they've given you basically they've given you the network address spaces to use in subnetting the network. So you're supposed to start with, let's say, this network address and divide it up into 1, 2, 3, 4 networks of 5,000 hosts each. And starting with this network address, you need to divide it up into 2 networks of 30 hosts each. These guys represent switches, right? And these are connected to routers, and so each connection to the router is a separate network. So we've been given one network address, we need to divide it up into 1, 2, 3, 4 subnets. And with this one, we've been given one network address, and we need to divide in 2 subnets, and then the same thing here and here. And I'm going to show you how you would go about doing this using some basic subnetting skills. Okay, so we'll start over here at router 1. Here's R1. This is router 1. We've been given the 192.168.2.0 address space, and we need to divide it up into 1, 2, 3, 4 subnets, 4 networks of 60 hosts each. So I'm going to show you how we go about that. Well, I've got my little notepad here, and I'll bring this up here. First of all, I want to talk about the way to do this. So what we can do is, by doing this, we can figure out what we're going to subnet it into by using what's called the magic number scheme. And the magic number basically says the binary place values in a binary number system of 8 bits. Here's 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, that each bit has a place value. So this one right here is the 128 bit. Why? Because this one in place value is 2 to the 8th power, or 2 to the 1, 2, 3, 4, 5, 6, 7, 8th power, which is 128. And this 0 right here represents 2 to the 1st power, or 0, right? Or actually 1 in the binary sequence. So first place value is 1, 2, 4, 8, 16, 32, 64, and 128, right? So by finding the magic number, we can subnet this network. So let's do that right now. What is the subnet mask that we're going to need? Well, right before you, right here, you'll see that what I've got is a /30 subnet mask. And in a /30 subnet mask, the last bit borrowed, the last one, is the magic number. And in this case, it's 1, 2, 3 over, which would be a 4. And given a 4, that means the networks would go up by 4. And then the zeros represent how many hosts we would have. And we would have just 4 hosts, or 2 to the 2nd power, 2 places, number of hosts. So that would not be enough hosts for 60 hosts in each network. And you can see here that we need 60 hosts in each of these subnets. So the way that we do that is we'd say, well, okay, which one of these magic numbers is going to work? Well, 64 is the magic number that would work, and it's 2 places over. So 1, 2. Okay, so it would be this one right here is what we'd need. So we would turn these guys right here into zeros. So 0, 0, 0, 0. So now I have 1, 2, 3, 4, 5, 6 zeros, and 2 ones. This last one is the magic number, which is a 64, right? So this would be a /26 network. Why? There are 26 ones borrowed. the number would be 255, 255, 255, and over here this would be 128 plus 64, which would be 192. And this would be a slash 26, which would equal 64 hosts, 62 of which would be usable because the first host address will be the network number and the last host address will be the broadcast address. So now we can create our networks. All right, our networks would be, in this case, 192.168.2.0 would be the first network. The second network would be, and I'll just copy and paste, copy and paste, and paste, and paste, 0, 64, 128, and 192. Each one of these would be a slash 26 network. So now we've taken the 192.168.2.0 network slash 24 and divided it into 4 networks. The first network is the 2.0, the next network is the .64, the next network is the .128, and the next network is the .192. And they are all now, instead of slash 24, slash 26. So this would be your 4 subnets that you've created, and each subnet can have the magic number of hosts. So the magic number in this case was 64, and so we'll have 64 hosts in each of these networks. And you can see that, quite frankly, it goes from 0 to 63, right? And this one will go from 64 to 127. 127 will be the broadcast address, 63 would be the broadcast address for that network, and then in this one it would go to 191, and this one would go to plus 64 would go to 255. All right, and once again, these would all be slash 26 networks. All right, now it's going to get a little more difficult when we go to this next network, and in this next network we need to also have 4 networks that we need to subdivide from a 172.20.0.0/16. Okay, we need to divide this address space into 4 subnets of 1,000 hosts each. And to do that, the magic number scheme is not going to work as well because we're no longer just going to be in this 4th octet over here. So to calculate that, I use a different method. And here's the method that I use for calculating 1,000 hosts in 4 networks. Well, if in subnetting, the 1s represent the network numbers, and the 0s represent the number of hosts. Okay, and in a regular 255.255.255.0 subnet or network mask, right? That's what I have here, right? 255, all these 1s, 255, all these 1s, 255, all these 1s, and then the 0, which are all these zeros. This is a slash 24 subnet mask, class C subnet mask, and you have 256 hosts, right? That's normal. Well, if we change this, right, and we say, no, what we're going to do is, I'll copy this, copy, and paste, and instead of having just 8 zeros at the end, we add an extra 0 here. Now, we've got a slash 23, we have a slash 23 subnet mask, and the number of hosts will double. So that'll be 512 hosts, right? And then we can just keep on going up, and every time we go up, it's going to double. So copy and paste, and I'll change this to a 0, right? And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, or 2 to the 10th power of zeros, and now that's going to be 1,024 hosts. Okay, and so you can see that this is very useful just by adding the more, as we add more zeros each time, the number of hosts double. So if I take this line and copy it and paste it, and then another 0. Now we have 11 zeros. Oh, by the way, this is now /22 /21. Now we have 2,048 hosts. Okay, and why is this /21? Because you just count the ones, and that tells you how many ones here. 8 ones here, 16, 17, 18, 19, 20, 21 ones, 2,048 hosts. And I'm going to keep going because I'll use this later. We're going to need this later as we go up to and divide it to 5,000 hosts per network. So this one would be 4,096 hosts on a /20. And there we go. And one more time, copy and paste. And this one will be 8,192 hosts in a /19, each time it doubles, network, right? Why? The host equals the number of zeros. So we have here, we have 8, 9, 10, 11, 12, 13 zeros. 2 to the 13th power is 8,192. We have 8, 16, 19 ones. It's a /19. And if we wanted to, I could write all these out in decimal format too. So the one we're interested in right now is, let's say, this 1,024, right? So what would the 1,024 be? We'll just go like this. In decimal, the 1,024 would be 255.255.2. Let's see here, .252.0. And how do I know that? Well, this is 255. This is another 255. And then if we add these together, right, these ones here, if we add, this is what they represent. 128 plus 64 plus 32 plus 16 plus 8 plus 4, we get 252. All right, so we would use this for our next network. So for this network right here of 172.20.0.0 /16, it's going to be 172.20.0 will be the first network, .0.0 that is, and it's going to be a /22 and that would equal 1,024 hosts, which is just enough to have 1,000 hosts per network. It's 22 over, 24 over. Copy and paste. And what would the next networks be? Well, what is the magic number on that subnet? On that subnet, /22, the magic number is right there. The last one borrowed is in the 4's place. It's 1, 2, 3 binary digits over. The place value is a 4's place. So the networks would be 172.20.0, and this one will be .4 network, and there's an 8 network, and there's a 12 network. So 0, 4, 8, 12, and so those will be the network addresses for this R2 subnetted into 4 networks of 1,000 hosts each.